All right, we ready to get started? This is Thursday, so you have homework due in 5 days. Here's the tentative schedule so you can see what's happening. I just want to remind you, Tuesday, September 24th is your first quiz. And what we're about, this is really kind of a big part of your first quiz, what we're about to learn today. That's part of the homework. So let's take a look at the instructions. The written Excel assignment are both in one assignment. You just have those few problems. I think there's only like 4 or 5 problems, but number 1 has 3 parts, number 2 has 3 parts, then a couple other problems. But you're using Excel equations. I want to remind you, when you hand in your homework, you don't hand in an Excel spreadsheet. You're writing the Excel equations out by hand and the result by hand, or type it up, it's up to you. But I'm just saying manually, you're not handing in an Excel spreadsheet. You're using the Excel spreadsheet to enter the equation to get the result, so you can then write that out also as part of your homework. This homework shouldn't take you too long, really. And at the end of today, with the information you're getting, especially right here, the hardest part is going to be right here. Right there is going to be the hardest part. Once you have the rest of this information right here, you'll have enough to do your homework. And the best time to do your homework is while it's fresh in your mind. Today, later today, whenever you can, while this is fresh in your mind. Because if you wait till Monday to do your homework, or even Tuesday morning, it just seems to slip out. A lot of it slips out, and then you gotta go back and watch the video, and you gotta try to remember what was said. So, here's the materials. Again, every week you pull up these instructions, you look at those materials, and this is basically saying, here's what you should be studying for the first quiz. Literally leads you right to the right materials. You know, I forgot to mention, I mentioned it just briefly yesterday about the textbook. I said, who doesn't have their textbook? And a lot of you said you didn't have it yet. But I forgot to say, you know, it's the same textbook from your 301 class. So, you know, a lot of you said you didn't have the textbook, but if you had it for 301, you still have it. We're using the same book. We're just starting out in chapter 8 is what we're doing. So you don't need to buy a new book. Okay, here's the assignment. Let's review it. Number 1, give Excel entries and results, finding Z using this Excel equation, norm.inv. This is the hard one right here. I believe if we go look at, I think I got the picture, and I posted the picture. So I believe number 1 has A, B, and C. So there's 3 of them to do, right there. You're gonna write 3 of these equations and 3 results. Number 2, I think is the same thing, let me look. Number 2, give the Excel entry and the result to find Z using norm INV. So it's the same thing. You're using this. Let's take a look. I think there's 3 of them. Let's take a look. 1, 2, 3 of them, A, B, and C. So there's that one right there. Again, you're writing this Excel equation and giving the result. You enter it in after you write it out and get the result and write it next to it. So there's 3 of those, no big deal. What you're doing is you're just figuring out, and here, I'm going to give you a hint right now. The second number is 0 for every one of these 6 problems. For number 1 and 2, the second number is 0. The third number is a 1. This is how you find Z using normal INV. You use a 0 there and a 1 there. And then this first number right there is going to be the tough part. That a lot of people are going to go, wait a minute, why do we do this? What is this for? I don't get it. And that's what you're doing for 1 and 2, A, B, and C, all 6 of those. It's that easy. Talk about it in a minute. I'm going to give it all. Number 6C, only part C, show detailed work solving manually and give the Excel confidence Excel equation entries and the results. So you're doing this one to find your confidence interval manually. This is the manual equation to find that confidence interval manually. But then, after that, you get the answer. You then got to show me you can use this Excel equation. Let me read this to you because I used abbreviations instead of symbols. Mean, plus and minus. Confidence is the Excel word. Parentheses. The first number is the significance. Want to make sure we're all on the same page. 90% confidence, how much significance?
10.
Very good. All right. The standard deviation, which will be given, then the sample size. So I'll go with words when I'm telling you what to put in the parentheses instead of symbols so we don't get mixed up. Significance, standard deviation, sample size. Those are the three numbers you put in there. This is asking for those Excel equations. You're going to have to do both a plus and a minus. So there's two of them for number 6C. This is after you do it manually, and then the two results should be darn close to each other. Maybe one's more exact than the other, depending on how you round it, but probably darn close to each other. All right, so there's those three, number 1, number 2, and number 6, C. Then this is number whatever, because it's not from your book. And this one, let me see, what are we doing here? Suppose some of the population is known to be normally distributed with a standard deviation of 1.2. A random sample of 5 observations or below, there's the 5 numbers. What is the 98% confidence interval for the population mean? Show your detailed calculations and work manually. So we're doing that one manually, just like this. Then it says, give the Excel confidence equation. There we are, we're back over here again. Both plus and minus, you have 2 equations there, to also solve it and give the results. And the manual result and the Excel result should be darn close to each other. Maybe not exact, because you're probably going to do some rounding here in this calculation. Let's talk about this formula right here. Matter of fact, I'm jumping to that right now. My notes say don't, but I'm good. I want to talk about this formula right here. There it is. This is your formula for the homework. This is the same thing I have up here, but I'm using words. And it basically says, you're given the mean, or you got to calculate the mean, like that homework assignment where I'm giving the 5 results. You got to add them together and divide by 5 and find the mean. So what? You got an extra step there. Once you find that mean, you're adding and subtracting the z. The z is based on whatever confidence or significant level is announced in the problem, times the standard deviation over the square root of sample size. Now let me tell you order of operations. Order of operations say, do this square root first. Next, divide it into the standard deviation. So you're doing what's in the parentheses first. The square root, divide it into the standard deviations next. Then multiply it times z. Then add and subtract that from the mean. That's the order of operations, or you'll get the wrong result. Order of operations is the #1 reason why people make mistakes. You've got to get those order of operations correct. Why do we take algebra? Because in algebra is where you learn the order of operations. That's all you needed. You could have skipped the rest of the class. All right, so there's that. Now, this gets you through your homework for this week, right here, but I want to let you know where we're heading. This is called a confidence interval when you're being given the population standard deviation. This is the formula we're using because in this week's homework, you're being given the population standard deviation. But listen, between now and the first quiz, you got to figure out how to recognize this one compared to the other 2. There's 3 of them, and they all look alike, 3 different confidence intervals. So here's how you tell the difference. Let me show you all 3 of them. Here's the names of them, right? Come on. Look, right here. The first one's called when the population standard deviation is known. This is this one. This is why we're using z, because the problem said the population standard deviation is. All right. Now here's the weird one. The second one says the population standard deviation is unknown. Don't let that fool you. You're still given a standard deviation, but it happens to be the sample standard deviation. And the only difference with that formula is this is the sample standard deviation instead of the population, and that z is a t. Let me show you the formula so you can see it. Now, I want to make sure you realize you're going to hear this again because this part's not on this week's homework. This is going to be on next week's homework. So you're going to hear this again, how to tell the difference between one or the other or the third one. But what you're looking at right now, the reason we're using that T and that S stands for sample standard deviation is because we don't know the population standard deviation. Now, the problem's not gonna reach out at you and say, hey, we don't know the population standard deviation. Instead, you're gonna read it carefully and you're gonna go, oh, this is giving me the sample standard deviation. That's when we're using this one. Let me say that again. If the problem is like asking for a confidence interval and it's giving you the sample standard deviation, that's the formula. This is the hardest part for the first quiz, is determining which formula to use. So this is the key words right here. If the problem is asking for a confidence interval and it's giving you the population standard deviation, Z. That's the formula. Everybody get it? Everybody with me? It's all about reading it carefully and understanding whether you're being given the population standard deviation or the sample standard deviation. And it may not even say the sample standard deviation is. It may say, it will just leave the word population off. It will say, and the standard deviation is. And you gotta look at it carefully and go, wait, did I just get told the populations or the samples? And you almost gotta assume it's the samples unless it specifically says the population standard deviation is. And that's the toughest part, is these two are the ones that everybody gets mixed up. The third one's a lot easier. All right, there's the two hard ones. Let me go back and I'll show you the third one. The third one is called a confidence interval for population proportions. Proportions are really easy to recognize, and you'll know which formula to use. Matter of fact, let me show you the proportion formula for confidence intervals. So again, 3 confidence intervals. There's the one with the population means given to us using that Z. Slide 10, in case you guys are gonna download that PowerPoint. Here's the second one that we just talked about. This is on slide 18. This is if we're not being given the population standard deviation, but we're being given the sample standard deviation. And now the third one that I'm just introducing you to, which is called the proportion, right there, slide 26. This is if you're given no standard deviation, that the things being talked about are just like proportions. Oh, 33% of females are gonna vote this way, or 60% of males are gonna vote this way, or something like that. And there's no standard deviation, but you're being asked for confidence intervals. You know it's gotta be this. This is the only one you would use if there's no standard deviation, you're being asked for confidence intervals. That's how you tell the 3 apart. All right, if you got this down, you made it through probably the hardest part of the first quiz. Being able to recognize which one of these to use, because you're probably gonna have all 3 of them on that first quiz. You gotta know which formula goes where, to which one. And don't let me trick you, there could be 2 of the same one. So, you know what to look for. It's all about the standard deviation. Let's go back to today's homework though, that we're only doing the first one. This one right here is the one we're focused on for this week's homework. The other one's for next week. This is why I call it the building block, because we're just focusing on one little part of the 3, not all 3 at the same time. What did I want to do? I want to do an example, I think. Before I do an example, I want to remind you, again, the confidence versus significance, right? Confidence is always the opposite of the significance. So if I said 80% confidence, you would tell me how much significance. Very good, 20%. The opposite of whatever I'm saying. If I said 40% confidence, what would be the significance? 60. They gotta add up to 100%, so it's always the opposite of whatever the confidence is. Or if you're only being given the significance, but this has to have, let's see, that has significance. Where's the one that has confidence? But this has to use confidence. You gotta know what the confidence is. If you're given the significance, the confidence is the opposite. If you're given the confidence, significance is the opposite. That's all there is to it. All right, so there's that. So now we go back to this calculation right here. I want to quickly review how we manually find that Z. All right, because you're going to solve there. I believe there's 2 homework problems where you got to show me manually you can solve this. You're going to have to find the Z. You're going to say use Z chart. You don't even have to give me any note. You're just going to find the Z. So let's review it real quick. Again, matter of fact, we're going to review it by looking at the first example, and then we're going to look at the Z chart, and we're going to find the Z used. Here's the first example. Here we go. A sample of 11 circuits from a large normal population has a mean resistance of 2.2 ohms. We know from past testing that the population standard deviation is 0.35 ohms. Determine the 95% confidence interval about the true mean of resistance of the population. Basically, I'm going to shorten this on a quiz. Just going to say, blah, 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 find the 95% confidence interval. Now, your thoughts are, which of these three formulas should I use? This is obvious, though, because this is the only one we're doing on this week's homework, but I want to show you the key words, how to recognize this. The key words were, we know from past testing that the population standard deviation is 0.35 ohms. It literally told you population standard deviation. That's how you know to jump to that formula right there using Z. Now, you're going to see, if you're reading through the book or you're reading through the PowerPoint, you're going to see these words. Margin of error, standard error of the mean. If you guys had me, we talked a lot about standard error of the mean last semester, or when you had 301 with me, so you should be familiar with this. And error, margin of error, I've only mentioned briefly, but to the right of the plus or minus on all three formulas, to the right of the plus or minus, that's called the margin of error. You definitely need that definition because, let me say it again, to the right of the plus minus on all three formulas, that's the margin of error. But you gotta determine which margin of error to calculate based on that standard deviation. Is it a population, is it a sample, or is there no standard deviation and we're looking at a proportion? The part where the standard deviation is being divided by the square root of the sample size, that's the standard error of the mean for this problem, because we're using mean, standard error of the mean. The other one, the right side, is the standard error of the mean, because we're using mean, but the proportion is called the standard error of the proportion. Now let me show you each one so you don't get them mixed up. Okay, right there, to the right of the plus or minus is called the margin of error. But the standard deviation over the square root of the sample size, just that part, that's the standard error of the mean. So there's two of them that have standard error of the means. The one using the T and this one using the Z. They both have standard error of the means. But the proportion does not. Let me go to the proportion. It has the square root of the proportion times 1 minus the proportion over the sample size. That's the standard error of the proportion. The part to the right of the Z. The whole thing to the right of the plus or minus is called margin of error on this one also. All three of them, anything to the right of the plus minus is called margin of error. That's easy. But this happens to be called standard error of the proportion, that part underneath the square root. Because there's no standard deviation involved. We're not using a mean either. We're using a proportion. So this is called standard error of the proportion. These are your, you know how those who've had me before, I hope you're already picturing the quiz. These definitions I really harp on are usually your multiple choice questions, right? Those are your multiple choice questions. Then the problems from the homework are pretty much duplicate the problems that will be on your quiz. They're always related for those who never had me before.
Is it what's in the square root or with the square root?
With the square root. With the square root. Anything to the right of the Z would be the standard error of the proportion in this case. And the standard error and mean in the other two.
The standard error of the mean has to have standard deviation?
Yes, right. Standard error of the mean has to have standard deviation and it's using the mean. If you notice the other two, let me get back to the T, has the mean on the left side, and the Z one also has the mean on the left side. So they're standard errors of the mean. But they're the only ones with standard deviation. Standard error of the mean. Standard error of the proportion is the one without the standard deviation.
The other one without the proportion, it was what, standard?
The one without the standard deviation right there, that's called standard error of the proportion.
The other one.
Standard error of the mean.
The other, okay.
Okay, but, so there's standard error of the mean, standard error of the mean, standard error of the proportion, but all three of them to the right of the plus minus, margin of error. Margin of error. So all three of them, margin of error is to the right of the plus and minus, but standard error of the mean and standard error of the proportion to the right of the Z and the T, and the blah, blah, blah. I think you got it.
Can you say that again?
Seriously? Are you serious? Are you being joking?
No, being serious.
Are you serious? Okay, here we go. to the right of the Z on this third one, this is a proportion, no standard deviation. That's called standard error of the proportion. The square root, anything to the right of that Z. Standard error of the proportion. Then these other two, to the right of the T, that's standard error of the mean. And then this one, to the right of the Z, that's also called standard error of the mean. So you got two standard error of the means and one standard error of the proportion.
And then the margin of error.
Margin of error is all three of them, anything to the right of the plus minus. All three of them, anything to the right. That includes the Z, that includes the T, and then proportions also use, don't forget, proportions also use Z. So you got two of them using Z and one using T. We didn't learn T in my 301. I don't know if the other one did, but we're hitting T next week. We're learning the T. Okay, let's go back to this week's homework. So here's how to do it manually. You have to do number, 6C and the unnumbered one. Those two are expecting you to show the manual process. This means all those who've had it before know what to expect. The pointer in the setup, showing me the numbers in that setup. Then there's some additional points to showing me at least one or two calculations, and then showing the result is another couple points. So that's how that works. Show the setup, show the calculations, show the results. Now let's get to you solving these with Excel. How are we doing on time? We're doing good. Let's use Excel to solve these. Two of the problems are asking you to use a confidence, the Excel command called confidence function, in order to solve these. And the first number is the significance. The second number is the standard deviation. The third number is the sample size. So here we go. Where's my pen? Let's get to that example. Here we go. If we solve it manually, help me set this up manually, and then we're going to do the Excel. Equals, what's the mean in this problem? Can't hear you. 2.2, very good. 2.2 is the mean. Plus and minus, I'm writing plus minus so I can do it all in one equation. Go ahead.
So it's 1.96 for the confidence or 95?
Oh, hang on. 1.96 he's saying. What he did, he said 95% confidence. Now, I want to refresh this for those who are going, what? Here we go. 95% confidence. Here it is. That means we're going to use the 95% of the area underneath the curve in the middle. We take the opposite of the confidence, which is significance, which is 5%, split it in half because half is in each tail. We're going to look up only half, only this lower part right here, so that we can figure out what that Z is going to be. So if it's 95% confidence, is that what the problem said, 95%?
Yeah.
5% significance, split it in half, that's 2.5% in each tail. We're looking for 0.025 somewhere on there. I see it right here, 0.025. And, well, let me get my pointer so everybody can see where I'm pointing at. Hang on, here we go. Right, oh, where'd it go? Right there, right to the left of my pointer there, right to the left of it. So now if I follow that all the way over, I get 1.9, and if I follow it straight up, add a 6 to the 1.9, so this is 1.96, very good, times the standard deviation in the problem. Let me go back to it, hang on. And notice this is a population standard deviation. What is it? 0.35, very good, over the square root of what? 11, very good. Parentheses. There's the setup. You're going to show me some math. Maybe you're going to take the 0.35 divided by the square root of 11, give me that number, then take it, take that, give me that number, then add it to 2.2, there's your upper, subtract it from 2.2, there's your lower, you did it manually. Everybody with me? What are you going to add? Go ahead. No? Go ahead.
When you went to that chart, where did you put the 1.96? You said.
Oh, where do you put it? You mean in the formula? Like right here where the Z is?
Yeah, you said you should.
Right here.
But what you do with, you said you had to find the significance and go to the other chart.
Oh, to find the positive one?
Yeah.
Yeah, but it's going to be positive 0.196. But he's got a good question there. Right here, we looked up 2.5%, which was 0.025. Right there is what we looked up. He's saying, how would you look up the positive one over here? Think about this now. If 2.5% is in the tail, what is from there to the left? Let me say that again. If 2.5% is in that tail, what is from that point to the left?
97.9.
97.5. You would go to 0.975 on the positive side of this. This is how you look it up, the positive. I always go with negative because it's so much easier. But here we go. Go to the positive, 0.975, is that what you said? 975, so I'm looking for 0.975. Look at it right there. See my pointer is? 975, which happens to be 1.96. The same number, 1.96. So it doesn't matter if you go look at the positive side or the negative side. The negative side is just easier to look up and just ignore the negative, that's all.
So we could always use the negative.
You can use the negative or the positive because you gotta both add and subtract anyway. You're actually using both of them. So you're using both the plus and the minus. It's just you don't have to look them both up. They're both gonna be the same number.
We don't have to like do it both, but two.
You can do this in one equation, just like I did it, sure. As long as you're putting a plus minus, you can write it in one equation instead of two equations. Same with the Excel. We're about to solve this example using Excel, just like the homework, but we're gonna write it in one equation. We're gonna put plus minus. So here we go. Let me go back to this. Help you write the Excel. Hey, stop. Whoop, hey. Hang on. Here we go. Equals. No, hang on, right? Equals. Okay, come on. What do I put next? 2.2. Very good. 2.2 plus minus the word confidence. Here we go. Confidence. Did I spell it right? I think so. Confidence. Now, the first number is going to be what?
0.05.
Very good. Wow. Everybody here? I have up there that the first number's got to be the significance. The problem's giving you the confidence, but you know the significance. If 95% confidence, right here is going to be 0.05, 5%, the opposite of the confidence. Then it says the next number is your standard deviation, which is what? 0.35, comma, and the next number is the number of your sample, which is what? 11. There you go. And then give me the two results. Oh my God, this homework's too easy. You're gonna have it done before class is over. And it's almost over. Oh, too easy. Look, we just solved this. It's just like doing the homework. We only have one more thing to learn. How much time we got? We got an in-class. Oh, I almost forgot. We got an in-class. We love in-classes. Stop. Let's remind everybody how to do in-classes because there's a few people here that haven't had me before. You do it on your own piece of paper, put your name on it, you're handing it in, you did it on your own, but do it in a way that you can cross some parts out in case you did it wrong, because you're gonna get up, you're comparing with people around you, but the point is to get up and compare with two other people in two different rows than you're in. Different rows, go to different rows, compare with two people. You're not comparing answers, you're comparing the work. And as long as you have the same work, all right, go to the next personality. Oh, I got the same work again. You're right, hand it in. And you're done. Go and work on your homework. We got one more part to learn. All right, and just in case you got done early, I brought a life lesson. Right? Some people haven't had them before, don't realize you have to learn life lessons in this class. I can't let you out of here without some life lessons. Because I know you're going out in the world now. I mean, you can vote already. That's already scary enough. You gotta learn. So now we're going to do, you ready? How to find Z using norm IMV. So, right here. Here it is. Here's the key. Norm equals norm IMV. The second number is a 0, the third number is a 1. That first number is whatever the given confidence is, or if you're given significance, the opposite would be the confidence. But you got to add to it half the significance. Let me repeat this, everybody. This is the hardest part of today. The first number is whatever the confidence is. So if I said 90% confidence, what would be the significance? 10. Now, you got to take 90% confidence and add back half the significance. So you're adding 90 plus what? 5. So what would be this first number? 0.95 for 90% confidence. Which if you look here, 90% confidence, let me show you, equals norm IMV, parenthesis, 0.95, comma, 0, comma, 1. Every one of these, the second number is a 0, the third number is a 1. I'm trying to remember, the mean is always going to be 0, and the standard deviation is always going to be 1, or it's always going to be 1 when you're trying to look up what Z is off the Z chart. So, you have those first two problems, 1 ABC and 2 ABC, is asking you to find that Z using a normal INV, just like this. So you're gonna write 3 of these equations, and you know every one of them is gonna have 0 and 1, it's just what's that first number. Here's another example. Before I show it to you, 95% confidence. 95% confidence is the problem. We're looking for Z equals norm INV parentheses. There's the first number, comma 0, comma 1. Here's the first number. I said, what did I say? 95% confidence. So we're putting in 0.95 plus what? 0.025. 0.025, 2.5% on top of the 95% would be 97.5%, which equals 0.975, 0.975. 95% leaves 5% significance. Half of the 5 is 2.5. You add that back to the 95. This is the hardest part. It's kind of a crazy thing to do. What's happening is we're finding this point right there. And this point includes half the significance. That's why we're adding back half the significance. Did everybody hear that? I'll say it again. We're looking for the point that's over here on the right side, the positive. So all of that is the confidence plus half the significance. You're only leaving off the half the significance that's to the right of what we're looking at. This finds the positive Z. 99% confidence, before I show it. 99% confidence is how much significance? That's right. So hang on a minute. So we're gonna have 0.99 plus half of that significance. Tell me what that's gonna be in decimal form. 0.0 what? 0.005. Very good. Which then you add these up. 0.995 with a 0 in front if you want is the first number to find 99% confidence. 0.995. Because it's the confidence plus half the significance, which would have been a half of 1% added to it. How do we feel?
Good.
Anybody got the homework done? Oh my God, I'd have it done by now. I don't know what you guys are doing. Let's see. Here we go. You ready? What is that? Wait, I got to turn on the camera for this. If you're not here, you don't get any light. What is that? What is that?